Right, so it says the graph of y equals m divided by x plus n is sketched below. Determine the values of m and n. And what I like about moving from the previous example to this one is that in the previous example they asked us a and q. Here they're asking us m and n. Well, so what? It means nothing. They're just variables. But what we are going to need to do is find the value of m. In other words, what number sits on top of the x, and then the value of n. In other words, how much has this graph, the hyperbolic graph, been lifted up or down? So let's see if our methods picked up in the previous example work. So we know that we've got y is equal to m over x plus n. Now think back to what we are expecting. This is quadrant 1 and quadrant 3. Now when we're working in quadrant 1 and 3, we know that our m value is going to be positive. So that's a checking mechanism for us. When we're done, m must be positive. The next thing we know is that normally when we work with a hyperbola, all right, normally when we work with a hyperbola, we know that the graph comes in and its asymptote is the x-axis. Now can you see that this one, the asymptote, has actually been lifted up by 1 unit. So this is actually just moved up by 1. So can you see that we have to bring that change about by introducing a value for n, and we can see just by inspection that our n value is going to have to lift the graph up by 1 unit. And so consequently, when we lift the graph up by 1 unit, can you see that this piece here actually now is allowed to come and cross over because it's been lifted up by 1 unit. So we've got our n value to be 1. Okay, now remember I said standard practice. We first of all see the shift, and in this case, our shift is a +1. What are we going to do next? Well, I said to you now we're going to choose any point on the graph, which we're going to sub it in for x and y to make them vanish as variables. Now, the book actually says, let us have a look and substitute in the point 5, 3. But really, it's up to you which point you wanted to choose. If you wanted to choose another one, that would be up to you. I could choose any one that was lying on this particular graph, but to go along with the book, we're going to use an x value of 5 and a y value of 3. So x 5, y 3. Right, substituting in, we get 3 in place of the y is equal to m over 5 in place of the x, add 1. Now, can you see how magically what you've come from is an equation which had 3 variables, all of them being kind of mysterious, and now you've just got m. So what we're going to get is a common denominator of 5, I think, is going to help me here. So if I multiply by 5 on both sides, so I'm going to take this and multiply it by 5, and this side, and again multiply it by 5, we are going to get the following. Multiplying by 5, we get 15 is equal to, multiplying by 5, those cancel, I get plain m without that denominator, which is the thing that was irritating me, plus 1 times 5 is 5. So you can see that by keeping the m on the right-hand side and bringing the 5 across to the 15, we're going to get our m value to be 10. So I feel that I've done my job once I've written down that my defining equation is going to be y is equal to 10 over x, add 1. And as I've said to you before, whenever you get an answer, just make sure that it makes sense. We said that our m value had to be positive. We've got it being a positive 10 okay, which means that automatically, because it's positive, it would have plonked my hyperbola there and there. Lifting it up by 1 would have hoisted it above the line y equals 1, and so I'm very happy that what my final graph would have looked like is something similar to that, which is exactly what I've got, and so I feel that I've done my job properly.